Students, today we are going to discuss about the forces and its types. So, first we have to recall the definition of force. So, force as any cause which produces or tends to produce a change in the existing state of rest of a body or of its uniform motion in a straight line. We have to come across many types of forces in our real life, that are an attraction, a tension and a reaction. So, forces involving some parameters, that are resultant and components. So, resultant test means if two or more forces F1, F2, F3, etc. act on a rigid body, and if a single force R can be found whose effect on the body is the same as that of all the forces F1, F2, F3, etc. Put together, we have to get the single force, that is called resultant. So, resultant is nothing but the combined forces which is involving in the body, and the forces involving in the body are called nothing but components of the forces. So next we have to come across the fundamental theorem of parallelogram law of forces. So parallelogram law of force, it states that if two vectors A and B represent two sides of a parallelogram in magnitude and direction, then their sum A plus B, which is equivalent to the diagonal of the parallelogram through their common point in magnitude and direction. And next, the proof of the parallelogram law of force states that let the two forces be P and Q acting at a point A, and the force is P acting along the side AB, and the force Q acting along the side AD, then their resultant will be acting along the side AC, which is nothing but the diagonal of the parallelogram. So we have to write the resultant of two forces P and Q as AB vector plus AD vector, which is equal to AC vector. So next we have to deal with the analytical expression for the resultant of two forces acting at a point. So here again we have to deal with the parallelogram. So the two forces P and Q, acting along the side AB and AD, and the resultant will be acting along the side AC. So here the angle between the two forces be alpha. So the angle BAD equal to alpha. Since diagonal AC will represent the resultant, and let R be the magnitude of the resultant, so R is written as R is equal to P plus Q. So let R make an angle with P is phi. So angle CAB is nothing but phi. So next we have to draw the line CE, which is perpendicular to the line AB. So we have to get BC equal to AD equal to Q. And next we have to consider the right angle triangle CBE and the angle 90 degree which is in E. So here sin CBE is CE by BC, which is opposite side by hypotenuse. So we have to written as sin alpha equal to CE by Q. We get CE as Q sin alpha. And similarly we have to get cos alpha, which is adjacent side by hypotenuse, that is cos alpha is equal to BE by Q. So B is Q cos alpha. Next, from the right angle triangle ACE we have to get R square, that is resultant square. So R square is equal to nothing but the diagonal square, that is AC square. AC is written as AE square plus CE square. So AE is again written as AB plus BE the whole square plus CE square. Next we have to expand A plus B the whole square formula. So we have to write it as P plus Q cos alpha the whole square plus Q sin alpha the whole square. So next we have to expand this and we have to simplify this. P square plus 2PQ cos alpha plus Q square, since sin squared alpha and cos squared alpha is always 1. So we get R squared is equal to P squared plus 2PQ cos alpha plus Q square. So next we have to written as R, which is equal to square root of or P squared plus 2PQ cos alpha plus Q square. And next an angle phi is in P. So angle CAB is phi. Now from the right angle triangle ACE we have to get tan phi. So tan phi is nothing but opposite side by adjacent side, that is CE by AE. So C is nothing but Q sin alpha and A is nothing but P plus Q cos alpha. So the equation 4, which gives the direction of the resultant in terms of P, Q and alpha, and in the previous slide R, which is root of P square plus 2PQ cos alpha plus Q squared, is nothing but the magnitude of the resultant of two forces. So I hope you are understand about the analytical expression of two forces and by using parallelogram law of forces. Thank you.